Question 1. It says the buses to Ashby leave every 24 minutes and the buses to Barford leave the same bus station every 20 minutes. And it says a bus to Ashby and a bus to Barford both leave the bus station at 7:30 a.m. When will a bus to Ashby and a bus to Barford next leave the bus station at the same time? Well, it's really key to look here at 24 and 20. And it's about doing the 24 times table and the 20 times table until you both get the same number. So I'll carry this one on. We'll add 24 to this, and you can just use your calculator. So 96 and 24. Let's do that. So 24 and 96. Well, there we go. So it looks as though 120 is the right answer. But if you don't like that, you could look at the lowest common multiple of 24 and 20. Now the way I do this is I split it out like this, and I write my 24 and my 20, and I just do the prime factor decomposition. So I just want to look at prime factors. So that's 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3, and we have 2, 2, 2 and 3 as prime factors. 20 is 2 times 10, and 10 is 2 times 5. I then circle the factors that are in common to both, and then basically what is left is the factor that the other one wants to be the same. So 24 would like to get its hands on 5 under multiplication, and if you use your calculator, 24 times 5 is 120, and the 20 would like to get its hands on these two. So 2 times 3 is 6, and if you did 6 times 20, you'd also get 120. So that's not the answer. We've got to convert that into minutes. So that's 2 hours. And then you see, when will a bus to Ashby and a bus to Barford next leave the bus station at the same time? Well, if buses start, then it's 7:30 a.m. and 2 more hours is 9:30 a.m. So the answer here would be 9:30 a.m. Question 2. Amsol thinks that if you square x plus 5, you're going to get x squared plus 25 for all values of x. Well, let's see. We definitely get x squared, and here we'd get 25, so it looks as though it's true, but then he's missing these ones out. And we've got 5x here and a 5x here, so I'm afraid that x plus 5 all squared is actually equal to x squared plus 10x plus 25. So he is incorrect. And we have shown how we got to that answer. Question 3. I did this the longer way on the foundation paper, but for this paper, as it's a higher paper, I'll go over it a little faster. We know that the ratio of Kim to Molly in terms of the money they get is 2 to 5, and it clearly says that Kim is £105 less than Molly. Well, Molly has 3 parts more than Kim, because she has 5 parts for every 2 that Kim gets. So that 3 parts must be the £105. And if you do 105 divided by 3 on your calculator, you'll get £35 per part. Now we know that there's 2 parts here and 5 parts here, which makes 7 parts. So if we do 7 times 1 part, which is £35, then we would get, and I use my calculator here, 35 times 7, we get £245. So as there's £385 shared altogether, if we do 385 take away the 245, then that's £140 for Laura. Now, let's write it out as a treble ratio. we know that Laura gets £140. Kim gets 2 parts and 2 35s at 70. And Molly gets the rest. So you can either do 5 lots of 35, which is 175, or add these two up, which is 210, and then take that 210 away from 385 will also give you 175. But you want it to be in the smallest ratio possible, so I'll just divide these all by 35, and so you get 2 to 4 to 5. Now we've got to work out what percentage of the 385 does Laura get. So we didn't need to put these in their lowest terms. What we can do is just say, well, she had £140 out of the 385, and if you do 140 divided by 385, then you would get 0.36 recurring, and as a percentage you just times that by 100, so it had 36.36 recurring percent. So I showed you how to work out the money and how to write that as the ratio in lowest terms, just in case a question like that comes up on another paper that you practice with. Question 4. We have to identify 2 things that are not correct with this frequency polygon. Well, the first thing is that it's not supposed to be curved, it's supposed to have straight edges, like line segments, like a polygon. And secondly, the midpoints have not been plotted, so we're supposed to go between 0 and 4, which is halfway, and then plot 13, and then here halfway between 4 and 8, and then plot 24, and so on. So there's the 2 areas that are incorrect, and I've drawn the correct diagram. Question 5. A nice way of doing these types of questions is if you can see that an increase of 5% was a value of £2.30, then 50% would be, well, 10 times, which would be £23, so 100% would be £46. So why is that important? Well, the price of the rail ticket before was the amount you wanted, and that was the 100%, i.e. all of the whole ticket. Now it increased by 5%, and you worked out what that 5% was because it told you, and you worked back to the 100, which was the initial value. So that's quite a nice way of doing it. So if you had an increase of 3% and that was, say, £7, you would just have to work from 3% up to 100 using multiplication, not addition, by the way, and you could do that all on a calculator. So if you see those kinds of questions, just baseline it in this particular way and you'll quickly find the answer. Question 6. We have to work out the size of angle CFD. So let's label that here. Now, what we do know is that this is a regular pentagon, so all these lengths are the same. We also know that if we have a centre angle here, then each of these angles here, call it beta. Beta will be 360 divided by 5, and on the calculator that's 72 degrees. So all of these are 72 degrees. Now these lengths here are the same because it's regular, so these angles in total make 108 degrees because 108 and 72 makes 180, so these are 54. And then you'll find quite easily here that the centre angle and this external angle here to the regular pentagon are the same, 72 degrees. And then likewise this will be 72 degrees because you could work your way through from this side. Now we know that angles in the triangle add up to 180 degrees, and we've got 2 of them which make 144, which would leave this one to be 36 degrees. Didn't write that very well, so let's do that again. So that'll be 36 degrees for here. And you can write your statements out afterwards. I don't need to do that for you. Question 7. I've done this on the foundation paper as well, so if you want a slower explanation, then have a look at that one. So let's have a go. This one here, the rectangle, is 8.4 by 5.6, and on the calculator that gives 47.04 metre squares. And then if we work out the semicircle here, well, we know that the radius here is 4.2 metres. So the area of the green part will be pi times the radius squared, but halved because it's a semicircle. So if we do that, so we do 4.2 squared times by pi, and then divide by 2, then we'll get an area of 27.7088472. So if we add these two areas together, so we'll add the 47.04 metres, we get a total area, and that's going to be 74.7488.472 metre squares. And we know that Carol has been told that one box of fertiliser will cover 12 metre squares of garden. So if we divide that by 12, then we'll have, let's work this out, 74.7488.472 divided by 12. That will give us 6.2290706 boxes. But if we just bought 6, we wouldn't have enough, so we'd have to buy 7. And at $4.99, that will be $4.99 times 7, which is £34.93. So again, I've done a slower explanation on the foundation paper. Now, Carol finds out that one box of fertiliser will cover more than 12 metre squares of garden. Explain how this might affect the number of boxes she needs to buy. Well, she may need to buy fewer boxes. And I say may need because here, this number here, which was the actual area, so if we had 74.7488 roughly, and we divided that by 12, then we got 6.229. This is just rough. But if we upped this, and the price was, and the actual fertiliser is only going to cover, say, 12.1 metre squares of garden, i.e. a little bit more, if we divide that by 12.1, then 74.7488 divided by 12.1, well, that's going to be 6.177 boxes required, which is still 7, but this number could go up, which means that you'd have one box of fertiliser, but it will cover more garden. And if we do the extreme here, and say 12.9 metre squares, which is nearly 13 metre squares, and if we do 74.7488 divided by 12.9, well, we have 5.79 boxes, which means that she would only need to buy 6 boxes to cover it, as opposed to 7 for this case and this case. So she may need to buy fewer boxes. You can't say she will have to buy fewer boxes. And again, I've done that explanation on the foundation paper, so check that one out as well. Question 8. First of all, we've got to fill out the probability diagram, the probability tree. And in the round pencil case, we have 4 blue pens out of 7 in total, and then red we have 3 in 7, and in the square pencil case we have 3 blue pens out of 8 altogether, and the red is going to be 5 out of 8, and then again 3 out of 8, 5 out of 8. Now we've got to work out the probability now that the pens Samina takes are both red, so we're going to have 3/7 of the 5/8 here, which is going to give us 15 out of 56 as our probability. If you're not sure about the probability tree and how it works, then I have done a good explanation about why you times with probability trees, and I think it's under a playlist called, believe it or not, probability, so check that out. Question 9. There are 6 graphs shown, and we've got to write down the letter of the graph that could have the equation y equals 2 to the x. Well, y equals 2 to the x. If we let x equals 0, that's a nice value to choose, then we'd have y equals 2 to the power 0, and anything to the power 0 is 1. So it would kind of rule this one out, and this one. This could be 1, so that could be in. No. Could be. And no. So it's these two that we're looking at right now. So all we've got to do is put another value in and see what happens. Now if we have x equals 2, then y would be 2 squared, which is 4. So I would reckon that it's this one, because when x is 1 and 2, the value of the outcome is actually growing. In here it's actually declining. Okay, so D is what we would need here. Let's see if there's any more to this question. Okay, there is, and we've got part 2 here, and we've got x cubed minus 3x. But I would factor out an x first, and that would give me x squared minus 3, and then I would do a difference of 2 squares here, so that would be x plus root 3 and x minus root 3. And the square root of 3, you can do on your calculator, is about 1.7, okay, or thereabouts. So we're looking for x equals 0 to be a solution. That's when you put y equal to 0. Don't forget, when you put in things equal to 0, you just solve the brackets. So we'd have x is 0, x is minus root 3, and x is plus root 3. So we're looking for 3 cutting points. So the only one that has 3 cutting points is this one, and that was quite quick to see. So A it is. Not too bad. Question 10. We've got to simplify this expression, so I would write it all out like this. Let's look at the numbers first. 3 times 4 at some point, because it's all under multiplication, is 12. Let's cross those out, we've done them. M squared times m to the power 3. Well, we add the powers when we're timesing, so we'd have m to the power 5. Let's cross those out. And then here, it's the same as having r to the power 1 and r to the power 6. So we'd add those as well, and that is r to the power 7. And then we can write it here as shorthand, and we'd have 12 m to the power 5 r to the power 7. Question 11. Tom grows tomatoes, and the box plot below shows the distribution of the weights of 15 of these tomatoes. And we've firstly got to work out the interquartile range. So this is going to be the lowest value in the data. This is the highest value. And then we've got the lower quartile and the upper quartile here. And the difference between those is the interquartile range, i.e. looking at the spread of 50% of the data. Now in this case, we've got 150 here, 155, 5.6, 5.7, 5.8. So the lower quartile is 158, and the upper quartile, this is 160, 165, 166. So the upper quartile is 166. So the first thing we wanted was the interquartile range. So inter means between the quartiles. So we've got 166 minus 158, and that gives us 8. Okay, and that's going to be in grams. Now we've given the weights in grams of 15 of Jack's tomatoes, we've got to, on the grid below, draw a box plot. So we're definitely going to have the lowest value is 153. The highest value is 186. And then, well, how can we find the median? Well, if we have 15 tomatoes and they're ordered in size order, then we've got 1, 2, 3, 4, 5, 6, 7 this way, and then 1, 2, 3, 4, 5, 6, 7 this way, leaving us 170 in the middle. So the median is 170. If we want to look at the lower quartile, then let's have a look at these figures here. And we can see we've got 1, 2, 3, and then 1, 2, 3, leaving 164 in the middle. So that would be the lower quartile, so that's 164. And then the same for here, 1, 2, 3, 1, 2, 3, leaving 175 in the middle, so that would be the upper quartile, and there we have it here. So our box plot, nicely finished, like so, and I'll do all these the same colour now. Well, let's have a look what it asks for next. Compare the distribution of the weights of Tom's tomatoes with the distribution of the weights of Jack's tomatoes. Well, let's have a look what we can see. It's always good to compare the spread, i.e. the interquartile ranges first. So we can say, first of all, that Jack has a larger spread, i.e. the interquartile range, and we must give values here. So let's have a little look at the first one. Well, we know that was 8 grams here versus how many grams have we got here? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then it's always good to compare the medians. And the median here was 162. So if we just jot that down here, so the median is 162 in the first case, and then it was dead on, we can see here, dead on 170 here in the second case. So we can write our statement. Jack has a higher median weight. Let's just write that properly. And we'll give values as well, 170 grams versus 162 grams. Question 12. The diagram shows a piece of wood in the shape of a cuboid, and the piece of wood is 3 by 20 by 1.2. Now, when I should say that differently. I should say 3 by 20 by 120. That caught me out for a second. So that's 3 centimetres by 20 centimetres, and I'm going to have it all in centimetres. That's 120 centimetres. And the mass of the piece of wood is 8 kilograms. Now, the piece of wood will float in seawater if the density of the wood is less than the density of the seawater. And it says in a large pool, 1 litre of seawater has a mass of 1030 grams. So we know that density is how much mass you can pack into a given volume. So D equals M over V. So the density of the wood is the mass of the wood, which is 8 kilograms, over the volume. Now, we'll probably have this in kilograms per centimetre cube because I've put everything in centimetres. So it'll be over 3 times 20 times 120. And we can do the conversions afterwards if we want to. So we're going to have it in kilograms per centimetre cube. Now, we can do a bit of cancellation here. So you can use your calculator if you wish. So I'm going to have 60 times 120 at the bottom because 3 20s are 60. And then I'm going to halve this number and halve this one. And then halve this number and halve this one. And then halve this number and then halve this one. So I've actually got 1 over 15 times 60 kilograms per centimetre cube. Now, what that means is, if I do the calculation for the denominator, so that's 15 times 60, that's 900. So that's 1/900th of a kilogram per centimetre cube. Okay, so it might have been better for me to work in metre cubes, but hey, I went into centimetre cubes, so it doesn't really matter as long as I have the same units for the seawater. So the density of the water now, this being wood here, is going to be the mass, which is in grams now, so 1030 grams, over the volume, and the volume is 1 litre. Now, did you know that 1 litre is 1,000 millilitres? So what we can see from here is, I don't know if you know this, but 1 mil or 1 millilitre will be the same conversion as 1 centimetre cube. Okay, so 1 millilitre of water will be 1 centimetre cube's worth. So what we've got here is 1030 grams over 1000 centimetre cubes. And all we've got to do is convert the top number to kilograms. Well, that's easy enough. That's 1.03 kilograms per 1000 centimetre cubes. So if we want to know how much it is in kilograms per centimetre cube, we just got to do 1.03 and divide that by 1000 on the calculator. So 1.03 divided by 1000, and that gives me 0.00103 kilograms per centimetre cube. And then if we convert the 1/900th, that's going to have some ones in it, I think, some recurring parts. So 1 divided by 900, and that as a decimal is 0.001 recurring kilograms per centimetre cube. So I think all we've got to do now is underline this here. So it will float if the density of the wood is less than the density of the seawater. So the density of the wood is 0.00, and we're going to do lots of ones here, even though we don't write a recurring decimal that way, as you know, but just for argument's sake. And then the density of the water, we've got 0.00103. And they're both in kilograms per centimetre cube. And I just want you to understand that to one significant figure, they're the same. But to the second significant figure, you can see that the wood has more. So this is actually more. So the density of wood is less than the density of seawater. Well, it's actually more. So it will not float. So the wood will not float. And I think if I was doing that question again, bear in mind I've only just seen it for the first time, I think I would do kilograms per metre cube, so I would have converted these units here to metres. But you've got a calculator, so as long as you get it in the same units, you can then do the comparison. So I think that's a tough question for me anyway. I would have probably kept that question till one of the last ones on the paper. Question 13. Show that the equation x cubed plus 5x minus 4 equals 0 has a solution between x is 0 and x is 1. Well, we can write it as f of x is x cubed plus 5x minus 4. And then f of 0, and you can use your calculator, that would be 0 cubed plus 5 lots of 0 minus 4 will just give you -4. F of 1, so if we put 1 in place of x, we'd have 1 cubed plus 5 times 1 minus 4, which would give us 1 plus 5 minus 4, which is 6 minus 4, which is 2. Now, what we can see is that at 0, the function was 4 units below the x-axis, and at 1, it was 2 units above. Therefore, there is a change of sign, therefore root between 0 and 1. There's many ways of ending that sentence there. You could say, for example, as there is a change of sign, there must be at least one root, and you can use inequalities. So you could say something like this. There is at least one root in the interval, and then just state this instead. Part B says show that this equation can be arranged to give, or rearranged it should say really, to give x equals 4 over x squared plus 5. Well, when I do the A-level ones, I always work backwards, what I do with my students anyway. So I start from the answer, and then I just work backwards, and then just times both sides by the denominator, and then you have x cubed plus 5x, and then that's equal to 4, and then you take 4 from both sides. Okay, of course work forwards as well. There's no way the examiner can tell whether you work forwards or backwards, so you know, try both ways. As long as you can do it both ways, that's fine, but if you want to do it really fast, then I would work backwards. Now, the last part here, I'm going to try and insert a video into this video and see whether that works. So we want to start with x0 equals 0, i.e. our first value of x to be 0, and we want to input it into this iterative formula. And this is the idea about part B, to get it into an iterative formula. And we want to do that twice, and therefore we can find an estimate for the solution of this cubic. So let's see if this video works. So for this question, if we want to have our starting value as 0, you can do it quickly on your calculator. So you just type in 0 and press equals, and that means the last thing in the calculator's memory is 0, and that's what a and s will be. So we just do 4 divided by bracket, and then we just type in a and s, i.e. the 0 value, squared plus 5, And what that will mean is it will just put 0 in place of a and s. So we can press equals and we get 4/5 or 0.8. We then can press the value again, the button again, rather, equals button, and it will put 0.8 in place of a and s, and it will save us a lot of time. So we can just press equals again, and there's our second value as a fraction. If we want it as a decimal, there we go, 0.709, and we can just keep doing that, like so. So if we do another one here, let's say we had to start with a value of 0.2. Well, we press equals, we then do 4 divided by bracket a and s squared plus 5, and we just press equals, so as a decimal 0.793, and then the next one 0.710, 0.726, and you can see here it's settling down to around 0.724, well, 0.72407 to 5 decimal places. So that's a quick way of inputting values into an expression without having to do the whole thing again on your calculator. So let's have a look what we've got here. We iterated twice and it didn't say what to leave your answer to in terms of how many decimal places, so I'd probably just write down what was on my calculator display. So our first iteration was 0.8 or 4/5, and our second iteration was this decimal or 100 out of 141, as the video explained. So that was our first and that was our second. So I hope that little insert helped. I'm not quite sure if it will work when I upload it, but we'll have to wait and see. Question 14, quite a difficult question, but if we have this sign for a fish, then we want to multiply it by something where it's decreased by x%. So let's write x% as x over 100. And for example, if we wanted something to decrease by 7%, we'd times it by 0.93 or 1 minus 7/100. So in this case, we're going to times this by 1 minus x hundredths. And it says, given that the number of fish halves in 8 years, work out the value of x. Well, this means that over 8 years, we've got to do that successively 8 times, so to the power of 8, and then we're going to end up with half the amount of fish that we started with. Now, the nice thing about this is we can divide both sides by this sign here. You could have called this y, it doesn't have to be a fish sign. And we would have 1 minus x over 100 to the power of 8 equals a half. Now the lovely thing is we've got a calculator, so that means 1 minus x over 100 is a half to the power of, well, 1/8. And I'm going to do that now. So 0.5 to the power of 0.125, I'm going to use that as a decimal. And that gives me 1 minus x over 100 is 0.917 00040432. I'm now going to rearrange for x, which I'm sure that you can manage to do without too much explanation. So I'm going to times both sides by -1, and then I'm going to add this 1 to both sides, and that will leave me x over 100, and then that's going to be 1 minus 0.9 and so on, which is going to give me 0.08299595568, and then that's x over 100, don't forget, so I'm finally going to times both sides by 100, and my final answer for x would be, so I'm just timesing it now, 8.299595568. I always give everything on the calculator display, and then I'm going to read the question. It said to 1 decimal place, so let's write that to 1 decimal place, and that's going to give us x is 8.3 to 1 dp. Now I think that was quite a difficult question. I think the difficult part was reminding yourself that if you want something to depreciate, you can times by this multiplier, the decimal. This 8 also was difficult because it was happening for 8 years. But this part here, if you started out with a value and then you only had half of it left, then really what you end up with, you've just got the multiplier here, would be equal to 1/2, because the value over the 8 years is just halving. So once you've got that cracked, then it's pretty okay from there on. Question 15. It shows a diagram of 2 pots, pot A and pot B, and they're mathematically similar, which means one is a direct enlargement in all directions of the other. So the area of the base of pot B, it says, is 160 centimetre squares, and we've got to work out the area of pot A. Now we've got a length factor here of enlargement to go from B to A. We have to go in terms of length from 10 centimetres to 8 centimetres. So you can work it out because 10 has to be times by some scale factor, say Q, to give 8. So Q will be 8/10 or 4/5. So that length scale factor is 4/5. So we want to find the area of the base of pot A, and we're given the area of the base of pot B. And that's an area, and an area is a length by a length squared. So you probably worked it out that the area scale factor is a length by a length, so it's going to be 4/5 by 4/5, which is going to be 16/25. And that's to get from B, don't forget, to A. If you wanted to go from A to B, it would just be the reciprocal, it would just be 25/16. But we want to go from B to A. So now it's easy because we've got 160 for the area of the base of pot B, and we just times that by the area scale factor, and we can definitely use our calculator here. So 160 times 16 divided by 25, and I get 102.4 centimetre squares. Incidentally, with these types of questions, always try and get down to the length factor. So if you're given the area of 2 mathematically similar objects, you can find the scale factor for the area and then square root it to get the length one, and then cube it up to get the volume one. And if you're given the volume one, you can cube root it to get the length and then square the length to get the area scale factor. So just to recap on that, L, A and V, if you're given the length, square it to get the area. If you're given the length, cube it to get the volume. If you're given the area, square root to get the length and then cube it up to get the volume. And if you're given one of them, you can always get the other two. Okay, so just know how to get from one to the other, and then you'll always be okay with this type of question. But you do need to practice a few of them to get the hang of it, because in the exam it can be a lot of pressure, and then these rules can go out of your head in no time. Question 16. I think one of the most difficult questions on the paper. What I'm not going to do is try and find the lower bound and upper bound straight away. I'm just going to mess around with a over b, square root, and see what I come out with, and then go from there. So what's the most that a over b can be? Well, I'm going to let a be its maximum and b the minimum. So I'm going to have 6.435, divide that by 5.5135, and then what's that going to be? That's going to be 6.435 divided by 5.5135 on my calculator, and that's going to be 1.167135 214, and then I'm going to square root that, so, and that's going to give me 1.080340323. I'm just going to underline that and leave it for now. Now I'm going to do a min and a max, or lower bound, upper bound. This is b rather. So let's just get that right. So we're going to have 6.425 divided by 5.5145, and that's going to give me on my calculator 1.1651100164, and then I've got to square root that, and that's going to give me 1.079402689. Now, just on the aside here, I've looked at the upper bound of a and b and done that and square rooted, and it gave me 1.0802, which is not as high as this value here. So I'm definitely going to call this upper bound of v. And if I look at the lower bound of a divided by the lower bound of b square rooted, that's 1.0795, which is not as low as this could be. So this is going to be my lower bound of v. Okay, so now let's answer the question, and it says, by considering bounds, work out the value of v to a suitable degree of accuracy. Well, this is the difficult part, I think, because you've got to say, okay, this number here has got to round to a number the same as this would. Now, if we can find the number that they both round to, then that will be a suitable degree of accuracy for v. And we want to push it as much as possible. So we could first of all say, well, hey, they both round to 1, so let's call that v. But we can probably push it a bit further. We could round it here, this one to 1.1, and then this one also to 1.1. But we can push it a bit further. We could actually say, let's make this 1.08, and let's make this 1.08. Okay, because that's to 3 significant figures, and this is 3 significant figures. If we went any more, then they wouldn't be the same number. So the idea is about pushing them for as much as you can, and then you can actually get a suitable degree of accuracy. That's the best explanation I can give. Like I said, these aren't my strongest type of questions, but that's the value I would give, and that is 1.08. Question 17. The diagram shows a solid metal cylinder, and it tells you the base radius and the height, and it says it's melted, and all the metal is then used to make 270 spheres. Okay, now it tells you that each sphere has a radius of half x centimetres. So we find an expression in its simplest form for h in terms of x. So I'm just reading this question for the first time, so forgive me for being a bit slow. So I'm going to find the volume of the cylinder first, and that's going to be pi r squared times the height. So I'll put C for cylinder here. Now the radius is 3x, so it's pi times 3x all squared times h. So that's going to be 9x squared pi h. So that's going to be the volume of the cylinder. Now it says that all the metals used to make 270 spheres. So for one of the spheres, well, we've got the volume of a sphere is 4/3 times pi times the radius cubed, and that's going to give us 4/3 times pi times x cubed over, well, 2 cubed is 8. A bit of cancellation here, so we're going to get pi x cubed over 6. And it says that 270 of those are made. So what we do know is that 9x squared pi h is equal to 270 of these tiny spheres. You can use a calculator at any point here, don't forget. I know that 3 is going to 270 90 times, and 3 goes into 6 twice, and then 2 goes into 90 45 times. So that gives me 9x squared pi h equals 45 pi x cubed. So I can go from here, and I want to have something for h in terms of x. So I want h equals. So from here, I'm going to divide both sides by 9x squared pi. So the pi's cancel. The x squares cancel with 2 powers of x here to leave just x. And then 9 5s are 45. So h is just 5x. So not too bad. Sorry if I was a bit slow for that question, but that's how I would do it anyway. Question 18. Here we've got to make m the subject of this formula here. So we have f is 4 minus 3m all over 5 plus m. So let's get rid of this horrible denominator here by timesing both sides by it. So we times both sides by 5 plus m. Then we'll have f lots of 5 plus m equals, well, we'll just have the numerator left here. Then we'll expand this out here, so we'll have 5f plus fm equals 4 minus 3m. And here's where people start to worry. You want m, the subjects, you want m on its own, and you've got 2 terms here with m in it. So just get them all onto one side, and then you can just factorise the m out. So if we add 3m to both sides here, we'd have 5f plus fm plus 3m would be equal to 4. Now let's get this on the other side. So we're going to take 5f from both sides, and that would leave us with fm plus 3m is 4 minus 5f. And let's factorise out this m now. And with these types of questions, it's always about factorising. Okay, I've done these many times over the years, so don't worry too much. Just get them on one side and then factorise them out. So we've got f plus 3 equals 4 minus 5f. And then because this is a timesing relationship, we just want to divide both sides by f plus 3. And then, of course, f plus 3 divided by f plus 3 is 1. And we're just left with m equals 4 minus 5f over f plus 3. And don't get too worried if you have an answer like this. You might have 4 minus 5f over 3 plus f, that's the same. Or you might even have a minus out of the top, 5f minus 4 over f plus 3, that's the same. So there's plenty of variations you can get depending on what you do to both sides of your equation. So how you start is how you finish. So you won't always have the same answers. Question 19. Well, this is quite a difficult question, so we've got to be careful. We've got to calculate the size of the angle between the line AD and the plane ABC. So we want this angle here. Now, the important thing to do is try and find some of the angles that we can work out easily from the diagram. So in the plane ADB, because we're already given this angle is 60 and this one's 45, well, 60 and 45 makes 105, so this angle here would be 75 degrees. And then I can see another right angle triangle here, BDC, and I know this is 90 because it's shown, and this is 34, so this angle here must be 56 degrees. Had to think there for a second. So 56 degrees. So what have we got? We've got angle BDC 56 degrees and angle DAB is 75 degrees. Now, if we zoom in on the shape a little bit, then we can find this length here, DC, and how would we do that? Well, we know the tan of 34 is the opposite, which is DC, over the adjacent, which is 20. So DC is going to be 20 times tan 34. We also know that DB can be found because in the same right angle triangle we know that the cosine of 34 degrees is the adjacent over the hypotenuse, which is dB itself. So if we rearrange that, we can times both sides by dB, and that will give us dB cos 34 is 20, and then divide both sides by cos 34. So dB is 20 over cos 34. I don't have to keep writing the degree sign in. In fact, I missed it there. So I've got dB and I've got DC. Now, if I can find one more length in this right angle triangle, ACD, then I'll be able to get this angle for sure. And as I've already got DC, I'm going to go for AD. So let's create some space here. So using the sine rule, then AD over the sine of 60 is going to be BD over the sine of 75. It's hard to do this because I can't quite see the diagram, but let's have a look. So using the sine rule, AD over sine 60 is BD over sine of this angle here, which we said was 75 at the beginning. And we have BD as well. So I'm not going to do all this in terms of sines and coses. I'm just going to go straight for the kill and get some decimals down here. So from here, I know that AD is going to be BD sine 60 over sine 75, and I'm just going to decimalize that now. Don't forget, I know what BD is. It's here. So here goes, calculator in degrees. So we've got 20 divided by cos 34 times by sine 60, and then divide that by sine 75, and you can do that in as many steps as you want. So I have AD is 21.629,30853. That's on my calculator display. So that's really good. I'll change the colour here so we can see what we're doing. So I've got AD, I've got DC, and I need this angle, so we're going to use opposite over hypotenuse, which is sine. So I'll do this down here. So we know that the sine of the angle we want is opposite, which is DC, which is that 20 tan 34 number, which we can put in the calculator, so that's not going to worry us, over AD, which is the answer we've just got. So you can either put over ANS, because it's the last thing in your calculator display, or you can write it all out again, 20 tan 34 over 21.629,30853. So let's see how that goes. So I've got 20 tan 34 divided by, I'm going to try ANS and see what happens, and I get 0.6236986409. Let's make sure that's a decimal there. And of course I'm going to find the angle, so I'm going to do arc sine, or sine minus 1, or the inverse operation to get the angle. So let's see what the arc sine of this number is here. So sine to the minus 1 of ANS being the last thing in our calculator. Let's give that a try. Shift sine of ANS, and it gives me a final answer here of 38.586734477, and that's everything on my calculator display, but it wants it to one decimal place here, as you can see. So 38.6, and that's going to be degrees to one decimal place. So that's my answer. Sorry if I seem a bit dozy, but it's quite late, and this was not really the kind of question I wanted to do really late at night, but it's done now, and that completes this paper. So hope you understood what I did, and good luck. Question 20. For all values of x, we're given two functions, f of x and g of x, and first of all we've got to find g of negative 4. Well, g of x is x squared plus 2, so g of negative 4 must be negative 4 all squared plus 2, which is 16 plus 2, which is 18. Now we've got the composite function here, and all that means is that it's made up of two functions combined, and it means that we've got g of f of x. So if we know that g of x is x squared plus 2, then all that means is wherever we see an x here, we just put f of x, because it means g takes on f of x. So we would have, instead of writing x squared, we'd have the whole of the function f of x all squared, which is 2x minus 3 squared plus 2. And that's g f of x. So it can be handy of just doing another bracket here and thinking in the same way you did here. In place of x, you just put negative 4. Well, in this case, instead of x, we just put the whole of the function f of x. And we can multiply that out. Use a grid, I would. And then you've got 4x squared, you've got the 9 here, and you've got minus 6x minus 6 more. So you've got 4x squared minus 12x plus 9 plus the 2 is just 4x squared minus 12x plus 11. For the next question, we've got to look a little bit more carefully. We've got f of g of x equal to g f of x. And what we've got to do here is solve that equation. So we're okay. We've got g f of x here, and I forgot to see that in part B we had to show that it was this, so luckily we did get that right. I didn't think of checking it, but hey, there we go, it's already there. So that's g f of x, so that's the right hand side done. And all we've got to do is find f of g of x. So write it like this, and we know that f of x is 2x minus 3, so wherever we see an x we're going to write g of x in its place. So f of g of x is going to be 2 lots of, well, g of x is x squared plus 2, then we take away the 3, so that's 2x squared plus 4 minus 3, which is 2x squared plus 1, and that's what goes here. So we'll take 2x squared from both sides, and that will leave us 2x squared minus 12x plus 11 equals 1. We'll then take 1 from both sides, and would have 2x squared minus 12x plus 10. All of those parts here, if I enlarge this, all of those parts here are positive, even, and we divide both sides by 2 therefore, and we'd have 0 is x squared minus 6x plus 5, and then that looks nice that it's going to factorise x here and 5 and 1. They're both the same sign, and we need negative 6x. We want minus 5 and minus 1 more. And we've got to solve it. So if x minus 1 multiplied by x minus 5 is 0, then this is 0 or this is 0. So x is 1 or x is 5 are the solution points. Question 21. We're given 4 points on the outside of a circle, and we've got to prove that the angle ABC and the angle ADC add up to 180 degrees. Well, let's enlarge this circle here and let's get going. So I would draw radii in here first. And then basically I'll just put an X somewhere, say here. And then this has to be X because this triangle is isosceles. So this angle would have to be 180 minus 2x. And then it's just a matter of going round here. Call this y, then this would have to be y, and this is 180 minus 2y. Call this p, then this has to be p, 180 minus 2p, and then q and q, you can call them any letters you want. And then what you can see is, if you look at the angles that we wanted, and we wanted to show that ABC and ADC are 180, well, what have we got? Well, we've got Q plus Y for here, plus P plus X. Now, we've got to show that's 180. Well, the nice thing about this is, if you look around this point here, all these angles added up round a point must make 360. So 360 must be equal to 4 lots of 180. We've got here 1, 2, 3, 4, and you can use your calculator, and that makes 720. And then we've got minus 2q, minus 2y, minus 2x, minus 2p. And think about it of just adding minus 2q and minus 2y, minus 2x and minus 2p. If you don't like that, just think of minus and then have these added. Now, let's think very carefully. this is a multiple of 2, this is a multiple of 2, and each of these parts are multiples of 2, so we can halve both sides. And I hope you can see by just looking now that q plus y plus p plus x must be equal to 180. And you can do a little bit of algebra here, doesn't take too long. If you times both sides by -1 and then add 360 to both sides, you get 180 is equal to q plus y plus x plus p. There are other ways of doing this question. I'm not going to overcomplicate it, but one clue is you can use angle at centre is twice angle at circumference, but that's not quite so striking as just making it up as you go along, choosing any letters you want and just having a play around with some algebra. That's generally the way you can prove all of the circle theorems anyway.